So, let's say, for instance, you wanted to know how many grouping variables you had in each group. Now, a discussion question that I had posted was whether or not our one-way ANOVA required us to have an equal number of observations in each grouping for the one-way ANOVA. It does not. That is not an assumption of the one-way ANOVA. When we do the factorial ANOVA, it is a consideration. So it's worth just showing how to find that information. If we go into under analyze into descriptive statistics and we go to frequencies, we want to look at the levels of distraction because I want to see how many times I have a low, moderate, or high level of distraction. Click OK, and my output data, it's saying I have two missing files. I don't. I have six in each, and there, that is done. I'm not going to save my output data on that because that was just for an explanation. Then here we go. So if we go up here again to analyze, now we're going to look and see at, do we meet the requirements of the ANOVA for normality? And we could, of course, look at just our Levine when we run it, but there's always another way to do something, and sometimes it is good to look at something from more than one perspective. So the only variable that I want to look at is, do we have, as our dependent, our scores on the crossword, do we have a normality there? Are we lacking kurtosis? Are we lacking skewness? We have none of that. So if I go to options here, the mean, standard deviation, and I obviously want to click kurtosis and skewness to see that data, and I click OK, and I can look here at my statistics, descriptive statistics output for this, and it has N, our sample size is 18. This is our minimum, that is our maximum. Here is our mean, our standard deviation. And if we look at the skewness, it is negative 0.560, which is greater than our alpha of 0.05. Now, a reminder about alpha is whatever you select your alpha to be, and the range, I think, for behavioral research is 0.01, 0.01 to 0.05, but your alpha doesn't have, it's not written in stone that it's 0.05. It's your study, but typically that's just kind of a default alpha, and most tutorials will show that. So my 0.05 alpha, the negative 0.506, if I look at it as skewness, I'm looking, where does it fall? It must fall between -1 and negative and +1, falls there perfectly. Then if I look at kurtosis, I have negative 0.868, and again, that falls between the parameters of -1 and 1, and fulfills that requirement for normality. And I can report that, and then on my lab, and say I have met the ANOVA requirement, and I would probably also report my Levine statistic when we run that. Okay, so now what I'm looking at is I'm looking at John D. Morris's paper, or papers that with the light bulb, and all we're going to go through is how to follow these instructions for the light bulb with this data about scores on a crossword and the level of distraction. So we go to analyze, and we go down to our general linear model, which an ANOVA is a general linear model, and we go to univariate, which would help if I could do that, and I click on that. And our dependent variable, we said, was the scores, and our fixed factors or independent variables then become the levels of distraction. And so the first thing that I'm going to go to is the post hoc, and this will come up. And the factors for comparison there that we move over are going to be our distractions. And they have us running, I think it's pronounced Chefe, so we're going to select that. You could run additional ones. They really differ by very little as the output, but the lab specifically says for this one. But if you just wanted to play with the numbers, so we click continue because we have selected the appropriate box there. And then we need our estimated means is something that in the older version of SPSS was available when we clicked something differently. So we want to make sure we go to the estimated means, and we want to go ahead and move over distractions. You can drag it over too if that is something that speaks to your soul to do. I'm just making sure that I have selected all the possible discussions. Oh, so now I want to go to my options box, and we need to make sure that we select descriptive statistics. We want the estimated estimates of effect size, and we want the observed power, and of course we want to do the homogeneity tests, which would be our Levine. We do not need to click anything else there. Now it is worth mentioning that in SPSS there is a just to run an ANOVA. However, you would have to do your Cohen-D formula to determine your effect size. When we run it through the univariate general linear model, we can ask it to produce our effect size. So we click OK, and then we have our output data. So you'll see here we have our between subjects. We obviously have a sample size of 18. We have 6 of each. We have our means displayed here, and we would discuss those comparably. So when we look at our Levine statistic, if you look here, our significance value based on the mean is 0.598, which is greater than our alpha of 0.05, and we can reject the null and confirm that we have homogeneity of variance based on that. If we go down to our test between subject effects, let me pull John D. Morris's papers so that I make sure that I am not, if we want to look for our effect size, we are looking under this, under our partial eta squared data. And so that is where we're going to find our effect size. Let's see, the ANOVA F ratio, the F ratio for the ANOVA and your omnibus are going to be found, your F ratio is found there. And the paperwork, the lab's corresponding paperwork points out that our p-value, our significance value, is the most significant information here, ironically. This is confirming that we're using an alpha of 0.05. And so when answering the questions regarding omnibus, we're looking at the F value. And so we can say that the F value here is 21.295, which signifies that there's roughly 21 times the variation between the groups amongst those means. And then, let's see, we've discussed the effect size and the observed power, okay? The observed power here is the probability of finding a difference among the means this large if does it exist in the population. And we can see that we're very likely to see that within the population based on the data that we've used. And the interpretation of that you'll find on the last page of the John D. Morris Lab 4 file, and that perhaps will help. Here's our estimated marginal means. And then our last thing that we're going to look at is our post hoc, which is our CHEF-A. I think I'm pronouncing that correctly. And I'm going to stop recording just for ease, and then what I will do is record from the CHEF-A on.